100 Facts about electromagnetic induction. Historical context. 1. Discovery. Michael Faraday and Joseph Henry independently discovered electromagnetic induction in the early 19th century. 2. Faraday's experiment. Faraday's famous experiment involving a coil of wire, a magnet, and a galvanometer demonstrated the principle of electromagnetic induction. 3. Lenz's law. Heinrich Lenz formulated a law that describes the direction of the induced current in terms of the change in magnetic flux. 4. Maxwell's equations. James Clerk Maxwell's unified theory of electromagnetism incorporates Faraday's law of induction as one of its fundamental equations. Fundamental principles. 5. Magnetic flux. Magnetic flux is the measure of the amount of magnetic field passing through a surface. 6. Changing magnetic field. Electromagnetic induction occurs when there is a change in magnetic flux through a conductor. 7. Induced electromotive force, EMF. A changing magnetic field induces an EMF in a conductor. 8. Induced current. The induced EMF can cause a current to flow in the conductor. 9. Direction of induced current. The direction of the induced current is determined by Lenz's law. 10. Rate of change. The magnitude of the induced EMF is proportional to the rate of change of magnetic flux. Applications. 11. Generators. Generators convert mechanical energy into electrical energy through electromagnetic induction. 12. Transformers. Transformers are used to step up or step down the voltage of alternating current. 13. Induction motors. Induction motors are widely used in industrial applications, such as pumps and fans. 14. Eddy currents. Eddy currents are induced in conductors moving through magnetic fields, leading to losses in energy. 15. Magnetic braking. Electromagnetic induction can be used to create magnetic brakes for vehicles. 16. Metal detectors. Metal detectors operate by detecting changes in magnetic fields caused by metals. 17. Wireless charging. Some devices use electromagnetic induction for wireless charging. 18. RFID tags. Radio frequency identification, RFID, tags use electromagnetic induction for communication. 19. Electromagnetic shielding. Electromagnetic shielding protects sensitive equipment from external magnetic fields. 20. Magnetic levitation. Magnetic levitation, maglev, technology uses electromagnetic forces to suspend objects. Theoretical aspects. 21. Faraday's law. Faraday's law states that the induced EMF in a closed loop is equal to the negative rate of change of magnetic flux through the loop. 22. Lenz's law. Lenz's law states that the direction of the induced current is such as to oppose the change in magnetic flux that produced it. 23. Maxwell-Faraday equation. The Maxwell-Faraday equation is a mathematical formulation of Faraday's law. 24. Electromagnetic waves. Electromagnetic waves are produced by accelerating charges, and their propagation is governed by Maxwell's equations. 25. Relativity. Electromagnetic induction can be explained in terms of special relativity. 26. Quantum electrodynamics. Electromagnetic induction is a fundamental phenomenon described by quantum electrodynamics. Additional facts. 27. AC generators. Alternating current, AC, generators use electromagnetic induction to produce electricity. 28. DC generators. Direct current, DC, generators use commutators to convert the induced AC into DC. 29. Self-inductance. A conductor carrying a current can induce an EMF in itself due to its own magnetic field. 30. Mutual inductance. The ability of one coil to induce an EMF in another coil is called mutual inductance. 31. Inductors. Inductors are components that store energy in a magnetic field. 32. Transformers. Transformers are devices that use mutual inductance to transfer electrical energy between circuits. 33. Eddy current brakes. Eddy current brakes use electromagnetic induction to slow down or stop rotating objects. 34. Magnetic resonance imaging, MRI. MRI machines use electromagnetic induction to create images of the human body. 35. Electromagnets. Electromagnets are temporary magnets created by passing a current through a coil of wire. 36. Magnetic flux density. Magnetic flux density is the strength of a magnetic field at a point. 37. Magnetic field lines. Magnetic field lines are imaginary lines that represent the direction of the magnetic field. 38. Magnetic permeability. Magnetic permeability is a measure of a material's ability to conduct magnetic flux. 39. Magnetic susceptibility. Magnetic susceptibility is a measure of a material's response to an applied magnetic field. 40. Diamagnetism. Diamagnetic materials have a weak negative magnetic susceptibility. 41. Paramagnetism. Paramagnetic materials have a weak positive magnetic susceptibility. 42. Ferromagnetism. Ferromagnetic materials have a strong positive magnetic susceptibility and can be magnetized. 43. Antiferromagnetism. Antiferromagnetic materials have opposing magnetic moments that cancel each other out. 44. Ferromagnetism. Ferromagnetic materials have opposing magnetic moments that do not cancel each other out completely. 45. Superconductivity. Superconducting materials have zero electrical resistance and can exhibit perfect diamagnetism. 46. Magnetic energy. Magnetic energy is stored in a magnetic field. 47. Magnetic force. Magnetic forces act on moving charges. 48. Biomagnetism. Many living organisms produce magnetic fields. 49. Magnetohydrodynamics. Magnetohydrodynamics is the study of the interaction between electrically conducting fluids and magnetic fields. 50. Solar flares. Solar flares are intense bursts of electromagnetic radiation caused by magnetic activity on the sun. 51. Aurora borealis. The aurora borealis, or northern lights, is a natural light display caused by charged particles interacting with the Earth's magnetic field. 52. Geomagnetic storms. Geomagnetic storms are disturbances in the Earth's magnetic field caused by solar activity. 53. Compass. Compasses use the Earth's magnetic field to determine direction. 54. Magnetosphere. The magnetosphere is a region of space around the Earth that is dominated by its magnetic field. 55. Van Allen belts. The Van Allen belts are two donut-shaped regions of radiation trapped in the Earth's magnetosphere. 56. Magnetic anomaly. A magnetic anomaly is a deviation from the Earth's normal magnetic field. 57. Magnetic reversal. The Earth's magnetic field has reversed polarity many times throughout its history. 58. Paleomagnetism. Paleomagnetism is the study of the Earth's ancient magnetic field as recorded in rocks. 59. Magnetic navigation. Some animals, such as birds and sea turtles, use magnetic fields for navigation. 60. Magnetic resonance imaging, MRI. MRI uses electromagnetic induction to create images of the human body. 61. Electroencephalography, EEG. EEG measures electrical activity in the brain using electrodes placed on the scalp. 62. Magnetoencephalography, MEG. MEG measures magnetic fields produced by electrical activity in the brain. 63. Electrocardiography, ECG. ECG measures electrical activity in the heart. 64. Magnetic particle inspection. Magnetic particle inspection is a non-destructive testing method used to detect defects in ferromagnetic materials. 65. Eddy current testing. Eddy current testing is a non-destructive testing method used to detect defects in conductive materials. 66. Magnetic levitation, maglev. Maglev trains use magnetic forces to levitate above the track. 67. Magnetic resonance force microscopy, MRFM. MRFM is a high-resolution imaging technique that uses magnetic forces. 68. Magnetic force microscopy, MFM. MFM is a technique used to image magnetic domains. 69. Magnetic storage devices. Magnetic storage devices, such as hard drives, use magnetic fields to store data. 70. Magnetic data storage. Magnetic data storage is used in various applications, including computers, audio and video recordings, and data centers. 71. Magnetic recording. Magnetic recording is the process of storing data on a magnetic medium. 72. Magnetic tapes. Magnetic tapes are used for data storage and backup. 73. Magnetic disks. Magnetic disks are used in hard drives and other storage devices. 74. Magnetic read, write heads. Magnetic read, write heads are used to read and write data on magnetic storage media. 75. Magnetic data recovery. Magnetic data recovery is the process of recovering data from damaged or corrupted magnetic storage media. 76. Magnetic particle imaging. Magnetic particle imaging is a medical imaging technique that uses magnetic nanoparticles. 77. Magnetic resonance elastography. Magnetic resonance elastography is a medical imaging technique that measures tissue stiffness. 78. Magnetic resonance spectroscopy. Magnetic resonance spectroscopy is a technique used to study the chemical composition of samples. 79. Magnetic resonance angiography. Magnetic resonance angiography is a medical imaging technique used to visualize blood vessels. 80. Magnetic resonance tomography. Magnetic resonance tomography is another term for MRI. 81. Magnetic resonance diffusion imaging. Magnetic resonance diffusion imaging is a technique used to study the movement of water molecules in tissues. 82. Magnetic resonance perfusion imaging. Magnetic resonance perfusion imaging is a technique used to measure blood flow in tissues. 83. Magnetic resonance neurography. Magnetic resonance neurography is a technique used to visualize nerves. 84. 85 to 100. 85. Magnetic resonance elastography. Used to measure the stiffness of tissues, especially in the liver and breast. Helps in diagnosing diseases like fibrosis and cancer. 86. Magnetic resonance neurography. Visualizes nerves in the body, aiding in the diagnosis of nerve disorders like carpal tunnel syndrome. 87. Magnetic resonance perfusion imaging. Measures blood flow in tissues, used in diagnosing stroke, brain tumors, and heart diseases. 88. Magnetic resonance diffusion imaging. Studies the movement of water molecules in tissues, used in diagnosing brain diseases like multiple sclerosis. 89. Magnetic resonance angiography. Visualizes blood vessels, used in diagnosing conditions like aneurysms and atherosclerosis. 90. Magnetic resonance spectroscopy. Analyzes the chemical composition of tissues, used in diagnosing brain tumors and metabolic disorders. 91. Magnetic resonance force microscopy. A high-resolution imaging technique that measures magnetic forces, used in studying magnetic materials and biological samples. 92. Magnetic particle imaging. A medical imaging technique that uses magnetic nanoparticles to create images, offering high sensitivity and resolution. 93. Magnetic data recovery. Recovers data from damaged or corrupted magnetic storage media, often used in forensic investigations. 94. Magnetic recording. The process of storing data on a magnetic medium, used in various applications like audio and video recordings. 95. Magnetic tapes. Used for data storage and backup, offering high storage capacity and durability. 96. Magnetic disks. Used in hard drives and other storage devices, offering faster data access compared to magnetic tapes. 97. Magnetic read, write heads. Used to read and write data on magnetic storage media, converting electrical signals into magnetic fields and vice versa. 98. Magnetic data storage. A fundamental technology in modern computing and data storage, enabling the efficient storage and retrieval of information. 99. Magnetic storage devices. Devices like hard drives and floppy disks that utilize magnetic fields to store data. 100. Magnetic anomaly. A deviation from the Earth's normal magnetic field, often caused by underground mineral deposits or geological structures.